Welcome back. Today we're going to talk about the graphs of sine and cosine, also known as sinusoids. When we talk about sinusoids, we're actually talking about two different kinds of graphs. Here's the first one. F of x is equal to a times sine, and you see sine in here for a sinusoid, but what we're going to see is sine and cosine are actually very closely related. So we've got a sine of bx plus c, and then plus d on the end here. Now this setup should look fairly familiar to you because all of these letters, a, b, c, and d, represent changes to the parent function. So the parent function sine of x, or in this case we could have f of x is equal to a cosine bx plus c plus d. All of these letters, whether it's sine or cosine, have to do with the way that it's shifting either left and right, up and down, the amplitude, which makes it taller or shorter, and the phase and the period, so how choppy it is. Okay, and so when we're talking about amplitude, we're talking about think about how loud something is. So the amplitude, you turn it up, that's how tall the wave is. Okay, in the case of sinusoids, it's half the height of the wave, meaning so from top to bottom. The new max is compared to 1 because a normal sine or cosine curve has an amplitude of 1, and so the absolute value of a is the amplitude. Okay, so the absolute value of a is the amplitude, and so if we find the amplitude of the following without graphing, we just have to be able to recognize which coefficient we're dealing with here. So the amplitude here is 4. Our amplitude here is 2, okay, because it's the absolute value of a, okay, and the amplitude here is absolute value of 1/3, which is 1/3, okay. So think about what that means in terms of our graph, what that would look like. This is 4 times as tall. This one is 2 times as tall. Now that negative is going to flip it over, but it's still going to be twice as tall. For 1/3, this is going to be 1/3 as tall. Okay, and so amplitude is the absolute value of a. All right. So let's take a look here for just a second. We're looking at a sine graph, a cosine graph. And so amplitude determines how tall it is. Period is the length of one full cycle of the sinusoid wave. And so when we're looking at period, let's just check out a graph right here. Okay, so I've got sine of x graphed here, and let's just take a look for a second. You know, I've got this max here of 1 is y, and then here I've got -1. That's where our amplitude comes from. So let's say I just put in a 2 here. See how it gets taller, or a 3, or a 4. See how it gets taller and taller and taller? Okay, so that's amplitude. Period has to do with how long the wave is. So check this out. If I go from 0 to the start of a new wave, so the start of a new wave for sine is at this midline, right? So this is all the way through 1. Okay, so the length is how much x it covers. So it goes this way, and then here starts over. My normal period is normally 2 pi. Okay, so for a normal sine or cosine graph. But period is really equal to 2 pi divided by the absolute value of b. In a sine curve, the b just happens to be 1, the number in front of x. So normally it's 2 pi divided by b, so b is 1, so this would be 2 pi. If I start to mess with this though, if I put 2 in here, see how it gets choppier? And so now instead of it going through a full S curve of being 2 pi, it's now pi. It's half as much because it's 2 pi divided by 2. What about if I made it 3? So check it out, it's even shorter, or 4, or 5, or 6, or 7. Okay? The more I increase b, the choppier it gets because the period becomes shorter. All right? The period becomes shorter. So it's 2 pi divided by b. So find the period. So period is 2 pi, which is my normal one, divided by the absolute value of b. And so in this case, it's going to be 2 pi divided by the absolute value of 3. So I just have to be comfortable with these fractions. So really this is 2 pi over 3 is my period. For this one, b is a half. So 2 pi divided by a half is equal to 4 pi. We didn't actually look at that, so let's look at that for a second. What if I did this as a half, 0.5? Check out how long this makes it. So now my S curve is 4 pi, which is my x value, long instead of 2 pi. So if it's a fraction for b, dividing by that makes the period longer. Okay, in this one, period is 2 pi over b. Well, check it out. This is a, right? And this is b. Just because a is not 1 doesn't affect the period any. So this is still 2 pi divided by 4, which is pi over 2. Okay, so that's how period works. Frequency. Frequency is how many times it's going. Okay, so frequency and period are very closely related. The number of full cycles graph completes in a unit interval, so per 1. So frequency is the absolute value of b divided by 2 pi. Okay, so the frequency of the function for sine 2x over 3, so 2/3 x, and interpret its meaning. When we look at that, that's actually going to give us an idea of what this looks like. So here, let me see, 4 sine 2x, 2x divided by 3. Okay, so check out the period here. A period is actually 3 pi, so let's look at how these are related. So it'd be 2 pi over 2/3, which would be 6 pi over 2, which is 3 pi, which makes sense because it's multiplying by 3 halves. And so if I did instead b divided by 2 pi, I would have, this is for my frequency, right? And so this would be 2/3 divided by 2 pi, which is equal to 4 pi over 3. Okay, so that's my frequency for that one. Frequency is not as important. So it's not, I shouldn't say as important. It's very important. However, it's not as commonly looked at as amplitude and period and phase shift. Okay, so frequency is a measurement that we use, and it's very important. It's we talk about frequency a lot in physics, but in math we're going to talk about the other pieces a little bit more. This next example puts everything together. So find the amplitude, the period, and the frequency. So this is the absolute value of a, and I like to line these out like this. 2 pi divided by absolute value of b, and this is b divided by 2 pi. Of this function right here. So what you can do is label your a and your b, and so amplitude is going to be equal to the absolute value of -3/2, and so that's 3/2 is my amplitude. My period is 2 pi over b, so over 2, which is pi, and my frequency is equal to 2 over 2 pi, which is 1 over pi. Okay, so there you go. That's exactly everything that we just did. It's taking those coefficients, understanding how all the pieces play together. Phase shift. Phase shift is another way to say left and right movement. Okay, we've done this with all of our parent functions so far. So check out where it lies. So f of x minus c, it's whatever's being subtracted inside those parentheses. So like when we had like an f of x is equal to, x minus 2 squared. This would be right 2, right? That would be essentially like phase shift. So whatever's being subtracted inside there is going to be my phase shift. And so if I have f of x is equal to sine of x minus pi over 2, it looks different because, oh, it's a pi over 2. But don't get confused. We're dealing with multiples of pi here because that's how sine graphs are constructed. They're constructed based on radians. And so when I do a subtraction of pi over 2, phase shift is whatever is the opposite of c. Whatever's inside those parentheses, it's the opposite of c. And so this is going to be right pi over 2. Okay? Right pi over 2. That's all there is to it. Because pi over 2 is a number, It's the same thing we've been doing, except it just looks a little bit different because it's got a pi and it's got a fraction. Who cares? It doesn't matter. It's whatever's being subtracted. So let's break it down. Our equations look like this. F of x equals a sine bx plus c plus d. Or f of x is equal to a cosine of bx plus c plus d. And this is my vertical shift. That's up and down. We're not going to really talk about that just yet. Amplitude is the absolute value of a. Period is 2 pi over the absolute value of b. And frequency is the absolute value of b over 2 pi. That's the basic breakdown of it, guys. So if you have any questions, let me know. But thanks for watching, and we'll see you next time.